CSE715. My ID is 232730004. My topic is BERT. BERT means bidirectional encoder representation from transformers. Let's see the overview. In the overview, we have introduction, BERT architecture, understanding BERT architecture, application of BERT, necessary equations of limitation, future development, ethical consideration, and conclusion. Let's see what is BERT. BERT, which is stand for bidirectional encoder representation from the transformer. In the state of the natural language processing model developed by Google, it is utilize a transformer architecture allowing to understand the context of word in a sentence by considering both the left and the right context simultaneously. BERT has achieved the remarkable result in various NLP tasks, including question answer, sentimental analysis, text classification by pre-training on large corpus of text data and fine-tuning on specific tasks. Let's see the BERT architecture. This is the basic architecture of the BERT. Now let us understand how the BERT architecture works. In the architecture, we can see transformer architecture, pre-training and fine-tuning, tokenization, input representation, transformer encoder layer, masked language model, next sentence prediction, output layers. Tokenization. BERT tokenization input texts into word pieces which are subword of parts of words. This allowing to handle out of the vocabulary word and capture richer symmetric meaning. Self-attention mechanism, in which within each transformer layer, BERT utilizes self-attention mechanism to weight the importance of each word in context of the entire input sequence. This allows BERT to focus more on the relevant word and less or relevant more. Pre-training and fine-tuning. BERT is pre-trained on a large amount of text data using two unsupervised learning tasks: masked language model, which is MLM, and next sentence prediction, which stands for NSP. After pre-training BERT, we can fine-tune on specific downstream tasks with a label data, allowing it to adapt the representation to the task at hand. Application of BERT. BERT has found numerous applications across various fields due to the ability to understand the context of word in a sentence. Here are some common examples. Natural language understanding. BERT is widely used for tasks like sentiment analysis, name entity recognition, text classification, and questioning answer. Its contextual understanding helps in accurate interpret the meaning of the sentence. Sentiment analysis. BERT can analyze the sentiment of a piece of text more accurately by considering the context in which words are used. Named entity recognition. BERT exists in NER tasks by the recognition and categorizing named entities such as name of people, organization, location, date, etc. Question answering. In the question answering, we can see BERT has been appealed to QA system where it can understand the context of the question and provide accurate answer from large collection of text or document. Search engine. BERT helps search engines like Google to understand the context of search queries better, leading to more relevant search results. It improves understanding or user intent, especially for longer and more complex queries. Language translation. In the language translation, BERT can enhance machine translate system by providing better contextual understanding of the source and target language. This helps in producing more accurate translation, especially for language with complex grammar and syntax. Now, let us see the necessary equations of the BERT architectures. BERT utilizes transformer architecture, which involve concepts such as self-attention mechanism and multi-head attention. Mathematical understanding of attention mechanism and feed-forward neural networks is crucial for the comprehending of BERTs. Let's see the equation. Scale dot product attention. This is the core self-attention mechanism. It calculates the weight between the query vector Q and all key vector in a sentence. Here are this equation. which stand for or QKV, which is a softmax question. Multi-head attention. BERT uses multiple self-attention to attend to different aspects of the relation between what each head transform the scale dot product attention independently, which different weight matrix for Q, K, and V. Feed forward. In the context of transformer encoded layer used in BERT, the feed-forward network is a relatively simple component. Here are some equations that captures it functionally. First, linear transformation. These transformers applies a weight of matrix W and a bias vector B1 to the input vectors. Active function, which is ReLU. Second, linear transformation. The final transformation applies another weight matrix WT and the bias vector B2 to the output of the activation functions. These are the y equal to W2 into Z plus B2. Limitation of BERT. BERT has a fixed contents wide size limitation. Its understanding of the long equation. It requires a large amount of computer resource for training and fine tuning. But contextual understanding is limited by the fixed context window size, although it is considered both the left and the right during the pre-trained stage. BERT lacks in explicit knowledge of the world. It learns more text corpora but does not have the access to the external knowledge base or common senses. It might produce bias and inappropriate response due to data it was trained on. While BERT captures synthetic and functional information well, in symmetric understanding is not perfect. It may struggle with tasks that require deeper symmetric reasoning or understanding subtitle of the nuance in the meaning. BERT models, especially large ones like BERT Plus, require significant computational resources for training and interfaces. Now see the future development of BERT. Anticipate the future in BERT, including potential enhanced in multiple understanding of this part of domain-specific knowledge. In the future of BERT and similar models will likely focus on the improving efficiency, scalability, and the performance on specialized tasks. This could involve refined pre-training techniques, exploring large model architecture, enhance fine-tuning capabilities, and adapting to a new language models and domains. Additional research may develop into addressing BERT's limitations, such as its inability to understand the context across multiple sentences or its reliance on the fixed length into sequence. Ethical consideration of BERT. Reflect on the ethical implementation of BERT's application includes the bias migrating and the privacy concern. Large model like BERT can inadvertently use bias present in the data they are trained on. Addressing bias in the training data and developing techniques to mitigate bias in cruel ensure fair and the equipment outcome. Privacy. When it comes to privacy and so on, a large language model like BERT raise concern about privacy, especially if they are trained on sensitive or personal data. Training large model like BERT requires functional resources which can be environmental implications. Training large language like BERT, exploring energy efficient training technique and minimizing the carbon footprint and model development are important consideration. Developers should also strive for the transparency in how language models are trained, evaluated, and deployed. Establishing accountability mechanism can help addressing concern to the relate to model behavior and decision making. Conclusion. In the conclusion, we can say BERT has significantly advanced NLP tasks and open door for various applications. NLP NLP has sparked a new era of research and development in this field. Its ability to capture contextual information by data has led to remarkable advancements in various NLP tasks such as classification, question answering, and language understanding. However, the development and the further development of BERT come with ethical considerations that must be carefully addressed. These include issues related to bias and fairness, privacy, misuse, accessibility, transparency, and environmental impact and regulatory complaints. Effort to migrate these concerns are crucial for the promoting responsibility and ethical use BERT and similar language models. Embrace the transformative potential of BERT and on its ongoing evolution in shaping the AI in the future. And that's for all. Thank you.